So the first thing we're going to be looking at here is the classifications of each substance we have. Our calcium acetate is going to be an ionic compound. It is composed of metal, or the metal calcium, and the acetate, which is a polyatomic ion. And an ion is formed when a nonmetal reacts with an ion. In this case, it's a nonmetal and a polyatomic ion, making an ionic compound. And then we have our iron sulfate here. So that is going to be an ionic compound as well. The iron 3 sulfate consists of the iron ions and the sulfate ions. Both are charged. And then it is ionic bonds holding this compound together. And then we have our iron fluoride here, which is also going to be ionic because we have, once again, that the ions of iron and the fluoride ions, which come together to make that charged, the ionic bonding there. And then our sulfur trioxide here is going to be a molecular compound. Sulfur trioxide is composed of the nonmetal atoms sulfur and oxygen, as we know, and they covalently bond together. That's what happens when you have those two nonmetals here. Next, we're going to be looking at the formulas. The formulas of our worded substances here. So our calcium acetate is going to be the Ca, our calcium here, and then our the acetate ions, which are here, and then our charge over here. And then the iron fluoride here is going to be the iron here, and then our fluoride here. And then since the fluoride has a -1 charge, it is going to take two fluoride ions to balance the charge on the iron ion. And then naming our substances here, this is going to be iron sulfate. The formula here indicates that there are 2 ions with a positive oxidation state, which is our iron here, and then 3 sulfate ions here, and then so the iron sulfate, which is, we have the fate here because those 3, and then we have the sulfur trioxide here. We have the 3 on the oxygen, which is going to give us oxide, the trioxide, and then the sulfur here. Next, we're going to calculate the molar mass of our formula here. So our first step is to find the atomic mass for every atom in our formula. So we have our chromium, which is Cr, that's going to be 51.99 grams per mole. And then we have our sulfur, S, 32.06 grams per mole, and our oxygen, which is 15.99 grams per mole. And then we're going to make an equation based off of the amount of each atom's weight. So we have 1 of the 51.99 plus 2 of the 32.06 plus 8 of the 15.99, which gives us a total of 244.03 grams per mole. And then we're going to calculate the mass of calcium acetate present in 0.65 mole. And step 1 is to calculate the molar mass using atomic masses. So as you can see, 40 for the calcium here, 40.08, and then carbon, 12.01, hydrogen, 1.01, and 15.99 for the oxygen. So same thing as before, 140.08, 4 12.01, 6 1.01s, and 4 15.99s, which is a total of 158.15 grams per mole. And then we're going to come to this slide where we are going to use the number of moles times the compound's molecular mass to calculate the mass. So we're going to take 0.065, and we have to cross multiply here to get rid of moles and take us into grams. So 0.65 over, or not over anything, plus or times 158.15 grams over 1 mole, cross these two out, equals 102.80 grams. How many liters of sulfur trioxide gas would be present at standard temp and pressure at 15.7 grams? First, we're going to find the molar mass here, which we just explained how to do that on the last slide, and we come out at 80.03 grams per mole. Step 3, calculate the number of moles. So we are going to take 15.7 grams times 80.03 over 1 mole, because we're going to divide here, and we're going to cross out the grams, giving us 0.20 moles. And then the temp at SCD is 273.15 kelvins, and the liters per atom is 0.0821. We are going to then calculate volume using temp and liters per atom and moles. So we're going to take that 0.20 mole times 273.15 kelvins over 1 mole, cross that out. We're going to get 54.63 kelvins times the amount of liters per atom, which gives us a volume of 4.48 liters. Lastly, we are going to figure out which contains more iron between our standard or our scientific notation here of 5.18 times 10 to the 23rd particles of our substance here, and then our iron fluoride. So first we're going to break the formula down. We know that there are 2 moles per iron per 1 2 moles of iron per 1 mole of our substance here, and then our 2 moles of iron times this is our atomic mass. So we're going to multiply, so this is how we calculate into moles. 6.02 times 10 to the 23rd is going to be 1.20 times 10 to the 24th, which we are then going to take our mass and divide 5.18 times 10 to the 21st over 1.20 times 10 to the 23rd and come out with 0.00432 here, moles of iron in our substance. And then we are, for the molar mass for our first step here is going to be to find the molar mass, which we can do here, 92.05 grams. And then we're going to take 180.5, which is how many grams of our compound here we have, and then multiply it times, we're going to divide here actually. So we're going to, we want iron, figure out how much iron is in there. And then we're going to divide 180.5 divided by 92.05. It's going to give us 1.96 grams. So that tells us our compound here, or our substance here, has more, our iron fluoride has more iron ions, than our, our iron sulfate. Yeah.